Today's topic is the secondary derivative. For the function, continuous function, y equals to fx, we differentiate the y with respect to the x. We obtained dy dx. This is the gradient. Gradient of the fx. We can also write as f prime x. If we differentiate the dy dx with respect to x, we obtain the d squared y dx squared. The second derivatives y with respect to the x can also written as f 2 prime x. First, we use the second derivative test to determine any relative extreme in the function. Use the second derivative determine the maximum or the minimum point in the curve, such as the curve. This point is the stationary point, the dy dx equals to 0. And the gradient here is the positive. Gradient here is the negative. So this is the gradient. Is the decreasing. This is concave down. So this in this case, dy equals to dx equals to 0. dy squared dx squared. The second derivative is the negative. This point is the maximum. Maximum point. This is the maximum. In this case, this is the stationary point. This is the dy dx equal to 0. And this gradient is negative. This is the positive. So the gradient is increasing. Increasing so the dy dx squared is the positive. So this is the minimum. This is the minimum. This is the concave up. If for the stationary, the dy dx equals to 0, dy squared dx squared equal to 0. In this case, this is the horizontal stationary point. such as x, y, 0. In this part, the directive, the gradient is the positive. This part gradient is also positive. In this part is the concave down. This part is concave up. This part is the gradient dy dx. So the gradient changes from positive to 0, then to positive again. Another case is that the gradient is negative. This is the from negative to 0, then to negative again. This is the dy dx. That is the negative. For example, we use the second derivative to determine the maximum and minimum. For this function f, we get the first derivative equals to 3x squared minus 3. For stationary point, fx prime equal to 0. So 3x squared minus 3 equals to 0. X squared minus 1 equals to 0. We get x equals to positive negative 1. So we get the 1 equals 2 minus 2. So this point is the 1 minus 2. F minus 1 equals to 2. So this point is the minus 1, 2. We get the second derivative equals to 6x. 6x, we get minus 1 equals to minus 6. Minus 6 is the less than 0. So this is the concave down. concave down. So this point minus 1, 2 is a maximum. Second derivative 1 equal to 6 is the positive. So this is the concave up. So point 1 minus 2 is a minimum point. Example 2, we use that x equals to x squared. So fx prime equal to 3x squared. The second derivative is the x2 prime equal to 6x. For stationary point, this is not equal to 0. We can get x equal to 0. When x 0, this point equal to 0. So we can get the small table. Fx x 0, 0. This is minus 1, 1. This the 3. Minus 6, 6. So this is the stationary point. This is the y equals to x cubed. This is the gradient is the positive. This part gradient is positive. So point 0.0 is a horizontal point of inflection. This is the gradient. This part. What does the second derivatives say about the graph of function? We can see that they have a curve from A to B, point A to B. We get the gradient tangent. So this is the x, y. This is the derivative gradient is increases. The second derivative is the positive. So, so this is the concave arc. The graph over a tangent line. If the from B from go to from A to B in this curve X, Y, the tangent line is here. So this is the Fx derivative is the decreases. Decreases. The second derivative is the negative. So this is the concave down. The graph below the tangent line. Tangent line. So the second derivative for the point of inflections, we can see this curve from point A, B, C. This point is the minimum. This is the maximum. For point C, from point C, so this is the concave, this part is concave down. This is concave up. Concave up. So point C is the from concave down change to concave up. Concave up. This is the point. So point C is the point. Point of the inflections. Inflections. This part is the concave down, concave up. This part is the Fx equal to 0. Second is the negative. So for this part is the Fx equal to 0. Fx second is the positive. From here we can see that second derivative confirms confirms the local maximum and minimum. From here, we can see that point C is the second derivative equal to 0, and concavity changes from down to up, changes the is the side. Then there exists a point inflections. Inflection. Now we continue the example of one. We can see from here we can see the fx equal to 0. We can get for stationary point. We can get equal to 0. We can get x equal to plus minus 1. Also, we can get a point f minus 1 prime equals to 2. Oh, no. This fx, this point. We can get the second. From point 2, we know that this is the minimum. This is the maximum point. For the second derivative equals to 6x we can get minus 1 equal to minus 6. So this is the concave down. Equal to 6. This is concave up. From here we can get the curve. This x, this y, this O, this is 1, 2, minus 1, 2. We can get that for fx equal to 0, we can get x equal to positive, negative 3 root, square root, and 0. So we can get the curve as this point. We can get second derivative equal to 0, this point. So this is the concave down. This part is concave up. Concave up. This is point is the maximum. This point, minimum. Point O, we can see this is the at this point, at point O, the concave changes sign. Changes sign from down to up at the point now. So point O is a point of inflection. So to this topic, we can get a summary. For the first part is use the second derivative, determine the maximum or the minimum for fx equal to 0. Fx 2 prime is the positive. This is the minimum point for the second derivatives is the negative. This is the maximum. The second is the fx equal to prime equal to 0. So this is the stationary point. Also the fx, the second derivative equal to 0. This is the possible horizontal point of the inflection. inflection. Third point is fx the 2 prime equal to 0. A possible point of the inflection marks a change in the sign of the concavity. This is today's topic. Thank you for watching.